All right, we got this. So let's continue our talk of inheritance. We got this week is kind of stuffed with content, so let's just jump right into it. We missed some of the content from Monday's slides. There's only 2 slides that I want to make sure I cover. The rest of it will be reiterated in today's example. It's like a softer example of what we'll talk about today. So I'm fine just getting that in today's content. But this extends object we have to talk about. Last time we talked about inheritance, where an object can inherit all of the state and behavior from another object, and actually, or from another class. Every single class that you write does use inheritance, including all the classes you already wrote, the song class, the problem set class, for what it's worth. Every single class that you've written does extend another class. If you don't explicitly extend anything, like for most of our classes, for every class we've written so far actually, except yet Monday's examples, if you don't explicitly extend a class, you implicitly extend the object class. So writing game item, public class game item, or public class game item extends object, these do the same exact thing. If you don't explicitly extend anything, you automatically get the object class as an extension. So absolutely everything in Java ends up extending the object class either directly or indirectly. So when our health potion extends game item doesn't extend anything explicitly, so it implicitly extends object. So health potion extends game object, extends object. So health potion does get all of the state and behavior from both the object class and the game item class. I think I said game object there. But game item and object class gets all of the state and behavior. So no matter what, you're going to be able to follow a chain of inheritance. If something extends something else, extends something else, extends something else, you're following this chain all the way through all of the things that something extends. Eventually, you have to get to something that doesn't either explicitly extends object or doesn't explicitly extend anything, so implicitly extends object. You will always, always, always in Java end up at the object class if you follow that chain of inheritance. Absolutely every class in Java does extend object either directly or indirectly through other inheritance. So what's in this thing? The 2 big methods that we've already used and that we will use in this class, we won't use any other ones, is toString and equals. These 2 methods exist in the object class, which means every single object in Java, no matter what type they are, what class they were created from, every single one of them has these 2 methods, the toString and equals. That's why absolutely every object in Java, we can say system.out.println and then that thing, that whatever that object is, a reference to that object, and the toString or the println method will call the toString method of that object, which it's guaranteed to have because it's in the object class. So these 2 methods, everything's guaranteed to have it because it's in the object class. We took advantage of this one time in, I forget, but we used the find for linked list. We used the equals method to check if 2 objects were equal to each other, and we didn't even know the type of those objects. It was a generic type based on our type parameter, and we were able to say .equals on that, and that was allowed because it's in the object class and everything extends object. Absolutely every object has these two methods. Okay, now let's get on to today's content. Override is kind of the missing piece that we need to talk about. It's superclass constructors. It's inheriting the state and behavior, and overriding methods. I think, is that a good list? I think that's the three major things that we talk about for inheritance. Those are 3 big concepts that you need to understand. Superclass constructor calls the inheritance to begin with, that those instance variables in the superclass will be instance variables of the child class, and which method is going to be called when you call a method, which has a lot to do with overrides. So let's talk about overrides. In this example, we had game item which was inherited by Health Potion, and Game Item was the superclass of Health Potion, or it's superclass and subclass. Game Item is a superclass, Health Potion is a subclass, or Game Item is the parent class and Health Potion is the child class. Either case, Health Potion gets all the state and behavior of the Game Item class. And if we add some behavior to Game Item, I want to add a use method that simulates using just by printing to the screen for now, that uses an item. Then the Health Potion has this use method. That's review from Monday. But what happens when we don't want to get all of the state and behavior from the parent class? What happens when there's something that the parent class does and we just don't want to print item used to the screen when an item is used? What happens when we don't want that? Well, we're going to override that method. So I'm going to say the Health Potion class, I'm fine with the use method just printing item used. I'm not, but for this example, we're going to say that's fine. But for the weapon class, I want the weapon class to actually do something else when item used is called, or use is called. And for that, I'm going to print out damage dealt and then whatever the damage is for this item. I'm going to override the use method. I'm going to use the @override annotation, just like our @test annotations for our test methods. I'm going to annotate this method as an overriding method and override whatever I inherited. Whatever I inherited, I'm throwing that in the trash and saying this is the new use method. So the use method for an object of type weapon only, the use method is going to be this overriding use method, not the overridden inherited use method. That one's gone for objects of type weapon. For objects of type Health Potion, there's no override, so we're going to use the inherited method, the inherited use method. Override in a single slide. But let's talk about it for a lot more time. This override annotation is technically optional. I shouldn't even say technically. It's optional. It's just straight up optional. Did I say that in the other one? But we're using the override annotation to make our intentions clear and tell the compiler, hey, I'm overriding a method here. It is optional. I say recommended. By that I mean I recommend it. Paul does not, for what it's worth. We disagree on this, so this is a case where, make up your own mind. I'll give my pitch. He can give his if you ask him, do we need override annotations? He'll be happy to curse me out and everything, say, you don't need those things. So I don't care which one you go with, but I like the override annotation. The difference between this is the override annotation is going to tell you, so this is the same exact code, same exact behavior and everything without the annotation. If your method has the same exact signature as a method that was inherited, then it will still override the method. So this use method has the same name, same number and type of parameters, and the same return type as a method that was inherited. So Java will say, oh, I guess you don't want that inherited method, you want to override it with this, and it will override the method. The danger with this is what happens when I have some typo. I have a capital S here instead of a lowercase s. If all four of those things don't match exactly, you won't get any errors if you don't use the annotation. You won't get any errors. You just won't get the behavior you want. And your code will just silently be wrong, which scares me. I don't like that. So I like using the annotation. With the annotation, you're giving the compiler a heads up. You're saying, hey, compiler, I am overriding a method over here. I'm getting something inherited, I'm inheriting a method, and I want to override that thing. So just letting you know that's what I'm doing, those are my intentions. Also, people reading your code, it makes your intentions clear if you have the annotation. It makes your code easier to read. But you're giving the compiler a heads up, and then you have this typo. You have this capital S. Instead of creating a new method with a capital S, so having use with a lowercase s and use with a capital S, and having two separate use methods, instead, with the override annotation, the compiler is going to say, yo, you told me you were overriding a method, but this doesn't match any signatures of any methods that you've inherited, so maybe fix your code, because your code's definitely broken and it's not going to do what you intend. So if you don't make any typos, like Paul never makes a typo in his life, then you don't need the override annotation. But if you tend to make typos, use the override annotation, give the compiler a heads up so it can help you out when you make little mistakes like that. And the readability, even if you're a perfect developer, you never make mistakes, which doesn't exist. It just makes your code easier to read. At a glance, I know I'm overriding a method here. With this one, it's not clear that I'm overriding a method, and it takes a little more brain power to look at this code, especially since all three of these classes are in separate files in the real world. Navigating between the files to realize that there's a method that's being overridden, it's a little trickier to follow what's going on with the code. Override annotation, got it at a glance. So the use method in game item can't be called ever. It'll be called through health potion. So if I have a health potion object and I call use on the health potion, this method will be used. From a weapon object, I cannot call this use method with the code as written. In this code, we'll see by the end of the lecture, we can do inside this, well, not this use method because I have a typo. Inside this use method, I could do super.use, and I still do have access to it from the weapon class, from within it. But with this code as written, if I create a new weapon object, I can't access that method from that object because it's been overridden. So only inside the method that's doing the overriding do you have access to the original method. I didn't finish up chat. What am I doing? For override, can the parameters have different names? Yes. The parameter names don't matter. So how does the compiler know which non-static inherited method will be overriding? How does the compiler know which non-static inherited method will be overriding? Your methods, you can only have one method of a particular signature. So if there is a method with that signature, it'll be overridden. If there's not a method with that signature, nothing's overridden. So it's that you can only have one method matching a signature. For example, if you have a different parameter list, two methods with the same name, same return type, but different parameter lists, that's an overridden method, which is, from Java's perspective, two completely different methods. To us, they'll look like the same one because they have the same name, but they're two completely different methods because they have different signatures. Even though we think of it as an overloaded method, it's two different methods. Okay, classes that inherit other classes explicitly still inherit from object implicitly. Yes and no. So health potion does not extend object directly, but it extends game item, and game item extends object. So game item inherits all of the state and behavior of the object class. So game item has all of object state and behavior. And then health potion inherits everything from game item, all the state and behavior from game item, which includes the state and behavior of the object class. So it indirectly is inheriting from object, not directly. So I can't put like extends object on here. That would not be the same thing. That would be a compiler error. But it does extend object through the game item class. So that's why I say either directly or indirectly. If you don't have the keyword extends, you extend object. If you do have the keyword extends, you only extend one class. You can only ever extend one class, but indirectly, it'll extend object through the game item class. Okay, let's do a memory diagram. And again, just like Monday, we're getting into more, we know the format for memory diagrams, so I'm not going to stress myself really as much by trying to use the tracing tool during lecture. I'll use these memory diagrams with the assumption that it'll translate to the tracing tool now that you know what all the buttons do, I guess. Yeah. You would annotate each method. The annotation is per method. Just like in our tests, we have @tests on every single method. We can't annotate multiple all in one go. Okay. So don't forget your super constructor call. I'm going to say that a lot this week. Don't forget your super constructor call. We create a new weapon. That's going to be a game item constructor call. Two constructor calls to create a single object. And that object will have all of the instance variables. State variables, I haven't called them that in years, but that's what I used to call them when the course was in Scala. All the instance variables from both classes are instance variables of the weapon object. So make sure you get your inherited instance variables, and both constructor calls on there. Same thing with health potion, extends game item. Make sure you get both constructor calls on there. That's an easy instant fail. Anybody comes to me and says, the TAs, all I did was miss a super constructor call. They failed me on this. Yeah, they should. That's what they're supposed to do. Even if you have game item here, but you miss game item here, it's an easy fail on the quiz. I don't want to hear it. That's it. I say it so many times in lecture because it's an instant fail. And it's one of the only ones for this content. I said this last time, but worth repeating. There's only two big things that we're looking for on the inheritance quiz, because most of this we already assessed you on with the classes quiz and the linked list quiz. We know that you understand how to call a constructor, create objects on the heap, create instance variable. Like, you've already done all that. References, bouncing all over the place. You did tons of reference stuff with the linked list quiz. We already assessed you on all that. If you passed all that, we don't have to reassess you on that. So a lot of the quiz is going to be just reiterating stuff you already know. The new stuff is the superclass constructor call and the thing we're about to talk about. When a method is called, which method is actually used? We have two methods named use in our code. So when I call use, which method is going to be called when we call use? So those are the two things, superclass constructors and which method is called when a method is called. Miss one of those, like in a percentage-based course, that should be a 50%, which is going to be a not pass on the quiz. So very important. Don't forget your superclass constructor calls. Very important way. It's one of the only ways you can show us on the quiz that you understand inheritance is by having your superclass constructor calls. So don't forget them. Nobody in my section better forget those. Hopefully Paul is stressing it as much as I am too. But don't forget your superclass constructor calls. All right, on to the next one. This one we haven't had a chance to talk about yet. We were getting to it on Monday, but we kind of ran out of time. So let's talk about this for pretty much the rest of the lecture. Is what method is called when a method is called. We're calling weapon.use. There are two methods named use and one class that doesn't even have a use method. So which definition is going to be called? And the short answer for this is it depends on the type of the object that's calling it. So we have weapon.use. Weapon results to this reference. Dot means follow the reference. And then use, we're calling use from this object. That object is of type weapon. So the calling object is of type weapon. We're going to look in the weapon class for a method named use that takes no parameters. And we find it right here, and this is the method that's going to be called. And we actually don't, the override annotation, it's optional. We don't actually look for the override annotation or do any of that stuff. We just look for a method with the appropriate signature in the class matching the type of the calling object. So it's the type of the object that matters here. And we'll expand that conversation in Polymorphism Week just a little bit. But I'll say it right now just for some foreshadowing. It's always the type of the object. I'm going to stress object every single time there because in polymorphism, we're going to get to a situation where the type of the variable does not match the type of the object, which is all of polymorphism is what that's all about. So it's always the type of the object. We're not looking at anything else. We're not looking at the type of the variable. I'll never say type of the variable for determining this. It's always the type of the object. And that's a big reason why we put the type of the objects on every object in the heap is so we can keep track of what type it is so we know which method to call. What class do we go to look for its method calls, for its method definitions. So we look at the class. Weapon, we call this through weapon. We look in the weapon class. We find a method matching the signature that was called. That's the code that's called. This is, as always, is a reference to the calling object. I don't have to say that anymore. We've been doing that for weeks. You've already been assessed on that multiple times. And that's how we figure out what method is going to be called. Potion.use, potion.use. We called use from this object here. Its type is health potion. We look in the health potion class for a method named use that takes no parameters. And we freak out because there is no method called use. So this is where inheritance comes into play. Because for the weapon class, great, that's just what we've always done ever since classes. For health potion, we don't find the method. So we searched all over the health potion class. We do not find it. We do not find the method we're looking for. So then we go to the header, the class header. It extends game item. So let's move on to the superclass and figure out if we can find this method in the superclass. Because health potion inherited all of the state and behavior from game item. Maybe game item has the behavior we're looking for, and it sure does. So this is the method that's called when we call use through an object of type health potion. Weapon and health potion got two different behaviors when use was called. From the code, it looks like we're just calling the same method twice, but since it was called through objects of different types, we found different use methods based on our search. Really the other half of your quiz. Class constructor calls and following the type of the object to figure out which method definition is being called. And for the quiz, you can better believe we're going to have multiple definitions of the same method in different classes and mixing up, is it overridden, is it not, all that kind of stuff. And that's the procedure. Honestly, I don't think it's too complicated. The only thing is there's just so much other stuff in your brain right now. Just don't forget this when you go into the quiz. Yep. It may or may not be there. If I were to guess, it's not going. Paul's in charge of making quizzes, so it's probably not going to be there. But it doesn't, like when we went through our search, like I never even mentioned the override annotation. You look in the weapon class, and if you find the method, then you stop your search. Once you find the method, you don't go into the superclass. So we never checked game item because in weapon we found the method. Nowhere in there did it bother us that the annotation is there or not. Better to just name the weapon use method something different? No. Just steal your answer. No. No, but I don't have I can't follow up on that too good. I'll try. I'll try to give you a one-liner for this. The actual answer to that question is no because of polymorphism, but that's a whole week later in the semester. Can I even do this? I can't really do it without diving into what polymorphism is. But with the use method being here and the use method being overridden, I think I can do this. We're guaranteed that anything that extends game item has a use method. So every single game item in my entire game, I know that there will be a method named use that takes no parameters. So if I rename that something else in the weapon class, I kind of break that guarantee. Like I still have that guarantee, but weapon's use method is going to be print item used. But if I want weapon to do something specific when the use method is called, I need to override the game item class because I'm going to have code throughout my program that's coded to just generic game items. Like my player is going to have, and we'll actually do this during polymorphism week, our player will have a data structure that stores a bunch of game items, just generic game items, not knowing what type they actually are. And then when we use those game items, we want its overridden use method to be called. So if we named it something different in the weapon class, we would get item used, not a weapon-specific behavior. So it's a deep question. I got a whole week later in the semester to give it a better answer, but that's my attempt at giving a brief answer to that. But trust me, we don't want to do that. Okay, let's talk about the two-string method. Let's take everything we just saw, everything we learned, and kind of smash it all together. So every class in Java extends object either directly or indirectly. We just talked about that. The object class has a two-string method, and we inherit that two-string method. So if we have an object And everything we've done here, we have an object of a type matching a class that we wrote and we didn't override the toString method. What happens when we print that thing to the screen? Or we can call toString directly, which made it onto the quiz last week. I think caused a little confusion. We can call toString directly, by the way. We usually call it through the print line. Usually we're printing to the screen for a lot of our cases, at least in classes. But we can, if we want to ever convert an object to a string, .toString, it's going to do it for us. So what behavior did we inherit from the object class? And we talked about this briefly before. We did actually do toString earlier in the semester, but now that we are armed with our understanding of inheritance, we can talk about what actually happened there. So weapon and health potion extend game item. Game item doesn't explicitly extend anything, so game item extends object. And here's the actual object code from Java with most of it removed so it can fit on a slide. The whole object class would never fit on a slide. So here's the code for the object class. And importantly, the toString method. This is the actual toString method that you inherit from the object class. We've seen this before. It's going to be the fully qualified class name @ and then some randomish looking hex value, which calls the hash code method. This is another method in the object class that we inherit, but kind of irrelevant to our conversations in 1.16 at least. Will be relevant in, actually, I don't know if they use this hash code method exactly, but will be relevant in 250. Will it? You build hash tables in 250. I don't know if they use the hash code method. Probably not, actually. But we're going to do our same thing that we did before to look for a method call. When we call toString on a health potion or weapon, let's do weapon because my cursor is on it. We call toString on weapon. So we create a new weapon, we do system.out.println weapon, and we want to know what method is going to be called. We do the same exact thing we did before. Weapon, we're looking for a toString method. We search, we don't find it, we go on to the superclass. Superclass, we look for toString, we don't find it, and we continue this search recursively. We go on to the next one. Extends object is implicit here, so we go over to the object class and look for a toString method. We do find it, so even when we're calling it through a weapon, we get this method for its toString, and that's what's printed to the screen, which gives us something like this. We're going to get the fully qualified name. This is package.classname @ and then some random to us hex value. It's not literally random. It has meaning to the compiler and Java and everything. It's random to us humans. We don't care what that value actually represents. It's roughly a memory address, roughly a reference, but that's what we're going to get printed to the screen. Not super useful. Almost never what you want. I say almost, but I've never had a situation where this is what I wanted. Not really what you want. In fact, even the official documentation from Java says it's recommended that you override this in every one of your subclasses. Like, don't use this toString method. It gives you a default toString method just so there is something there, so everything can have a toString method. But the developers had to just choose something to be the default behavior. And then they're like, okay, we'll give you something just so your code compiles when you try to call toString on your objects, but you should really override this because this is pointless. Why would you do this? So let's override this method. We can override this. Let's start by overriding it in the game item class. Game item inherits the toString method. We'll override it to be whatever we want it to be. And then weapon and health potion both inherit this definition of toString. So now our search goes, we want to print a weapon to the screen. We want to convert a weapon to a string. We start at the weapon class. We look for toString. We don't find it. We head over to the game item class, go over to the superclass, look for the method, and we do find it here. We find a toString method, and we stop our search. This is the method that we call. We stop our search, and we never find the object's toString method when called through weapon or health potion in this case. And in fact, from an object of type weapon, we have no way ever of being able to access that original toString method from the object class. We cannot access it anymore. So this is the toString method that we get. A weapon and health potion both inherit from game item, which overrides an inherited toString. So a decent amount going on there. And what if we want to override this further? Let's override this in both of the subclasses, and I'm purposely mixing up my annotation here. I'm not using the override annotation here, but I am here just to show you that both of them do the same exact thing as long as you don't have a typo. In this case, make sure you capitalize this S. If you don't capitalize the S, you get not what you want. But just to show that both of them do work the same way. So with this, we're going to override toString in the weapon class, and it's going to return this weapon damage, plus this dot damage. So we call this through the weapon class. We search for toString, we find this, and this is the method we get. Even though we inherited this method, and GameItem inherited the method from object and overrode it, so we kind of have 3 definitions of toString from the weapon class. Only one of them is ever seen. This is the only one that'll ever be called. In Health Potion, I snuck in a little keyword here. This kind of came up on Monday a little bit in some side conversation. But the Health Potion class, we're going to override toString, but we're going to do something a little sneaky. Something that we often do in programming is override something, but without completely replacing it. What we want to do is take the inherited functionality from a method and add to it. We want to say, okay, that's cool that you gave me some functionality, but I want to do more than that without throwing away everything, because our alternate would be to override, copy all this, paste it down here, and then add the functionality. And whenever we have duplicate code like that, it should be a red flag that says, hey, we should do something better. Whenever you have duplicate code and you want to update it, you have to update it everywhere where you duplicated it. Kind of the original selling point of inheritance to begin with. I have 100 classes that all have the same code. Let's get the common code extracted, put it in a superclass, and extend from that superclass. Now we have 1 copy of that code to maintain. We want to change that code. We don't change it 100 times. So same thing here. We want to reuse this code without retyping it or cut and pasting it. So we're going to call the method. Whenever we want to call an overridden method, we're going to do super dot. And that's going to call the overridden version of this method. So in toString, we're going to say super.toString, and that's going to say, look, I know this .toString is going to be this method, make it a recursive method, in this case, infinitely recursive. But I don't want this method. I want my inherited toString method from the superclass. So super is a reference to the GameItem class. It gets a little weird here because it's in an object. But go to the GameItem class and look for a toString method, finds it right here, and calls this method. So this call is going to call the overridden toString method in the GameItem class. And then add some functionality to it. I'm just, as a proof of concept, adding dash health potion to say, hey, this was called from the health potion class. Functionality is still just print to the screen, or not print to the screen, just some random text. I guess it's always going to be text. Yeah, good question. You can do it anywhere. So if, say, in the constructor, I wanted to call this toString method, I could do super.toString in the constructor. That'd be perfectly fine. From any method, I can call any of the overridden methods. But I can only go up 1. Let me take this question just in case this is the question I'm about to answer. What's up? I'm not 100% on this, but I think you can do both. You can do super dot or this dot or just the method name itself with nothing. I know this dot and the method with nothing would work. Super dot, I think, still works, even if you didn't override. I think it still will go to the superclass. We're about to do a memory diagram to make sure we make that explicit. But yeah, calling health potions toString is going to call another method, and we're going to get another stack frame for this method call. I didn't get the question, but I'm going to answer it anyway. You can only go up 1. Oh, yeah, because I got to be careful how I word this. You can only go up one method. Maybe that's the right word. One method with super dot. So for example, health potion, I no longer have any access. I cannot call the object's toString method anymore from health potion. I can't do super.super.toString. I can only go up one method. So super.toString is going to get whatever game item has for a toString method. Even if game item didn't override toString, it'll go up. What I mean by going up one method, super.toString will go to the superclass and start its search there. If it doesn't find a toString, it'll go up to the object class and still access it there. But if something in the inheritance chain already overrode an inherited method, we can't go up 2 overrides up the chain. So if we wanted the object toString method, we can access it from game item, but we lose our ability to access it down here in health potion and weapon, for what it's worth. That question usually comes up, so I wanted to answer it in case somebody's thinking it. Can we use super.gameItem to call the constructor instead of just super? I don't think so. I feel like we would. I don't think so, but I'm not sure. I never tried to do super.dot and then a constructor, since the other syntax would be fewer characters. Even if you can, I'm going to use the other one because it's fewer characters. But I haven't tried it, super.gameItem to call the constructor. But I don't know for sure. Okay, so let's see this toString stuff in action. We got our superclass constructor calls. We create our objects. All that stuff happened. Don't forget your superclass constructor calls. And we're calling printline, which will implicitly call toString. So printline will call toString. The important part of this for your quizzes is the general rule of thumb for your quizzes. I don't think I've said this in lecture before. I say this in office hours all the time. Is if you can see the code, if we gave you the code for a method, it's because you're going to be tracing it. Like if you have the code there, there are some few exceptions. If we have like if, else if, else if, else if, else, we might not hit every single one of those conditionals. Maybe each one's going to be hit in different versions of the quiz, more than likely. But if we give you a function or a method, it's because it's going to be used. It's going to be traced. So one common mistake, we try to avoid this as long as somebody catches it in the review process. If you're printing to the screen and we give you a bunch of toString methods like this, you're calling these toString methods. If you get to the end of your trace and you're like, man, they gave me 3 toStrings. I didn't need that stuff. Like you put it in your in-out, but you don't trace any of the stack frames for it. It's another red flag thing. Like you should look at your trace and be like, why didn't I use any of that code in my trace? It's because you were supposed to. Printline will implicitly call toString. This one gets tricky. I don't like this on a quiz because you have to just know some things. You just have to memorize some things about Java. Because printline is internal to Java. Anything that we don't give you code for, you don't have to trace. So the printline stack frame itself, you're not tracing. You don't have to put that stack frame on the stack, but knowing that printline weapon is going to call weapons toString method, you do have to trace toString in that case. So if that does come up, we'll try to just avoid that. But if that does come up and makes it onto the quiz and gets released in at least one of the versions, that is fair in the sense that I wouldn't say that's a broken quiz and we have to like update grades and do a whole big crazy thing. But I don't think it's fair in the sense of we shouldn't be doing that on purpose. But you should know what to do if that does come up. So if that does come up, it shouldn't, but if it does come up, just know that your toString method's being called. But in general, outside of toString, if we give you the code, it's because you're tracing it. If we don't give you the code, you're not tracing it. That question in general comes up quite a bit for memory diagrams. Okay. We did have what we try to do is explicitly call toString, and that did show up on a quiz. I think last week there was an explicit .toString. We try to make that explicit so you absolutely can't miss it. The toString method is being called, so you have to trace that toString method if the code's there. If we print something to the screen, like we print an array list to the screen, and you look at the code we gave you and there's no array list.toString definition, you don't have to trace that. Weapon toString, we gave you toString, you got to trace it. Okay, so hopefully that clears up. Hopefully that saves at least one of you passing a quiz. That you'll pass a quiz that you would have failed, or else I just wasted a few minutes. Okay, So this toString is going to be traced. So print line of weapon, we're going to look at the type of weapon, or 350, weapon, go to the weapon class, look for a toString method, we find it, we call this toString, easy day, weapon damage 100. This dot damage, this in the stack frame, just a little refresher, this dot damage 100. And then we get to the potion. We're going to call toString on the potion dot toString. That's going to call it from a health potion. The object is of type health potion. We look in the health potion class. We find a toString method. This is the method that's going to be called. The calling object was 480, so in the stack frame, 480. And then the first thing this does is call super.toString. This came up in a question, but to put the visual to it, this is another stack frame. This is a method call. It creates a stack frame. It's just like any other method call for all of our tracing purposes, but finding which method is going to be called is the new thing. Super.toString, we're going to look in the super class. We're going to look at the class header, extends game item, so game item is the super class, and look in the super class for a toString method. We find it directly, so we don't have to continue our search to the object class in this case. We call this method, put that frame on the stack. This is still a reference to the calling object, which gets a little weird. Super isn't a keyword we put on the stack or anything. But when we use super dot, the calling object is whatever the calling object was in that original stack frame. So whatever this was in that stack frame, it's going to forward this to the next one. This stack frame returns. I'm not storing it in any variable, so we don't need a return arrow here. For quizzes, we usually like to store values in temp variables just so things are more explicit. Here I'm not doing that, so no return arrow. And then this returns the whole thing. What this returned concatenated with dash health potion, and we get this as our return value. It depends on the exact situation. So what happens if potion doesn't have a toString? We would continue our search in the superclass. If the superclass also doesn't have a toString and the superclass extends object, then you should complain to your TAs and tell them, complain to Paul, because we shouldn't give that to you on a quiz. Because I don't expect you to memorize what the object toString class is, or what the did I say that right? The object toString method implementation is, the fully qualified name at, and then some random stuff. I don't expect you to memorize that, so. Did it really? Was it an array list? I thought it was an array list in that case. I might have to look at it. Can you send me an email about that to remind me, please? Send me an email, be like, it was, what week of quiz it was? And then I'll look up your lab section and see what quiz you had and pull it. What? Friday last week? Okay. What was the object type? And you didn't, and it wasn't with the linkless toString? Might be unfair. I'll have to see what the exact situation is. But can you still send me the email just to remind me? Because it might slip my memory. All right, and I'm actually at my last slide. I usually don't end early. I thought this was too much content, so I was going a little quick there. But now I kind of mistimed it. So if there are no other questions, nobody's going to ask questions after I say we can leave early. So let's just end it early.